right, 5.3 is on compound interest. And this is probably, of all the stuff this unit, one of the more applicable ones. I mean, obviously the word problems are applicable too, but this is good because you will be needing to take out loans and investing money and whatnot as an adult, and then you can get yourself in a good position. So, compound interest. We have this lovely formula that looks like this. A equals P times 1 plus R over N to the NT power. And what all that means is A is going to be your ending amount. P is your initial amount or your starting amount, the amount you invest. N is the number of compounds per year. That sounds really funny, but it's all based on a year. So if it's daily, it's 365. So if it compounds daily, it means it adds interest every single day. If it's weekly, there's 52 weeks in a year. Monthly 12, quarterly 4, semi-annually 2, annually 1. Then we have R as your interest rate in decimal form and T as your time in years. Now before you start freaking out, I will give you this formula. I will not give you what all the letters represent, so you do need to know that much, and you do need to know what the different ends. So if I tell you it's compounded quarterly, you need to know that that is 4. So let's go ahead and try one of our problems. So I'm going to go ahead and bring this up, and then I'm going to put here the formula A equals P times 1 plus R over N to the NT power. So I like to write out all this stuff. So we got A, P, R, N, and T. So it says we invest $500, that's going to be our P. And then we have 8 years, so that's T. 7.6% interest, that's going to be, move this 2 places to the left, so you have 0.076. And I write it as a decimal already, so that way we don't forget. And then it says interest is compounded quarterly. Quarterly, if we look right back up here, quarterly is 4. So we have an N of 4. And it says how much money will you have after 8 years? So there's our unknown. For the purpose of these problems, so we don't confuse you, your unknown will always be A. So we put that into our formula. A equals 500 times 1 plus 0.076 over 4 to the 4 times 8 power.
But for R, don't we have to add 1 or subtract 1 if it's decreasing or increasing?
That's a really good question. We take care of that because we already have the 1 here, so we do not need to add 1 or subtract 1. We literally just plot the numbers in. Here's the thing. If you have a calculator that does order of operations for you, then you can just type this in as it is. 500 parentheses 1 plus 0.076 divided by 4 parentheses caret key 4 times 8. The one catch is you do need to put parentheses around the 4 times 8 or multiply it out ahead of time to get 32, because if you don't, it will interpret, the calculator will interpret that you want to take what's in parentheses to the 4th power and then multiply the entire answer by 8, which will give you a much larger number and give you false hope that investing money gives you tons of money all at once. So if we put this into a calculator, 500 parentheses 1 plus 0.076 divided by 4 parentheses caret key 32, what do we get to the nearest penny?
$913.15.
$913.15. Now, that means in 8 years you gained $413.15. That's actually relatively good, considering 7.6% is way bigger than your average savings account. Now, there's one other type of formula, and that's what we call a continuous compound interest. That means that every second of every minute of every hour of every day, interest is being calculated on your account. So that is what we call, I like to call it the PERT or the shampoo formula. That's probably a little bit beyond your time, but there used to be a shampoo called PERT shampoo, and so it's the PERT formula, P-E-R-T. Here, A is still our end amount, P is still our initial amount, R is still your interest rate as a decimal, T is your time in years. The new piece is this E. E will come up on your calculator as e to the x. On most scientific calculators, it will be found by hitting second, followed by your ln, which is known as your natural log. That's beyond the scope of this class. So if you hit second ln, that will give you the e to the x. So make sure you just look for this. So we have, for trying it out, and this is another one you can just put it right in the function. So I'm going to write down here a equals p times e to the RT power. So I need a, p, r, and t. So a, we don't know. Now this time we're investing $1,000, and we invest for 8 years, and still at 7.6%, so 0.076. So when we put this into the function, it's a equals 1,000 times e to the 0.076 times 8 power. And it's easier if you just put parentheses around the 0.076 times 8, because some of you are going to end up rounding. And if we do that, what do we get for an end value?
$1,836.75.
Now, one thing you will discover very quickly is that initially, depending on how, if you compare compounding a certain number of times a year versus continuously, if you go from, say, once a year to continuously, there's a big difference. But if you look at daily versus continuously, there's not that much of a difference. It's usually a few pennies of difference of what you will get from a certain given amount of time. But that's it. It's a matter of plop and drop, as I refer to it, into a formula. So I want you to give it a shot. I have this problem for you. You got $5,000 invested into an account at 6.4% for 15 years. So first I want you to find out the amount if the account is compounded monthly, and then find the amount if the account is compounded continuously. And as always, write your summaries, bring your questions with you to class.